Okay, I think we're live.
Hi everyone, good afternoon. So today we're going to be presenting our webinar on gaining the competitive edge with LLMs for energy management. Some of you guys may know me. My name is Courtney. I'm the Customer Integrations Manager here at Edcom Energy. And here I have the CEO, Vedad Barami. You want to give a quick little
Yeah, hi everyone. I'm Vedad Barami, co-founder and CEO of Edcom Energy. Thanks for joining us today.
So some of you guys are aware of Edcom Energy and our clients, but if you're new to who we are an energy management software provider. We deal with a lot of different services, but today we're going to be talking explicitly about our AI Copilot and different LLMs for energy management. So just to give a brief overview of the agenda, we're going to start with an introduction to large language models and then go into those applications, and then applications specifically in the energy industry. And then we'll go into some benefits and drawbacks. Then we'll explicitly talk about our AI Energy Copilot and give a nice demo to show you guys exactly what we've been doing for the past few months and how we've been able to create this wonderful Copilot of ours. And then we'll end it off with some questions and answers. And as mentioned, I'm Courtney and I have Vedad here.
So we'll start with the high-level question. What is a large language model? Since ChatGPT came out in March of last year, it's hard to believe that it was March of last year. It feels like it's been with us for a very long time. It's really changed the way that we interact with data and the expectations that we have from co-pilots, from chatbots, and from our software in general. So the first few months, we saw that the use case just spiked up significantly, and more people were getting accustomed and were being introduced to these LLM systems. So what is an LLM? Really, it's a large language model. So what does it mean? It's basically a model that has been trained on a vast volume of text. So they took text from textbooks, they took text from the internet, they took text from YouTube transcripts, from movies, and they basically fed all this into a model. And what it is it's a text prediction engine. So what it does is the model has different weighting parameters, and the neural network basically is called a transformer, and it's able to take your input in and estimate what kind of output you'd like to have based on all the data that it's been trained on. Now, ChatGPT isn't the first LLM that ever existed. It's the one that most of us got introduced to this technology with. There's other competing solutions, open source solutions from other vendors as well. And we'll talk about some of that as well. These transformers learn the context by tracking relationships between text with internal mathematical models. So basically what they're taking is they're taking all the text, they're taking it as a token. They're saying each letter is a token, each word is a token. They learn what the expectation of the user is when you ask a certain question. ChatGPT was really good, and the differentiator is that they use something called RLHF, which is called reinforcement learning through human feedback. So there was a lot of actual humans who sat there and interacted with the model and improved the model for thousands of requests. And then the model learned based off the human feedback what kind of answers we like to hear. And that's what really was the differentiator between ChatGPT, the vast volume of data and the reinforcement learning through human feedback. And we'll get into how that's going to help with energy management and some of these LLMs as we move forward. But the takeaway here, LLM means large language model. It's a text prediction engine, essentially. So the applications of these LLMs are plenty. So right now we talked about ChatGPT. They're basically a communication layer for AI applications. So the LLM itself is the model. The chat interface is how we're currently most frequently talking to these models. That doesn't have to be the only way. So in some of our products, we've integrated LLMs, but it's not a two-way chat. It's just the LLM giving you insights into what you should be doing in terms of your answer. So it's not a chat interface, but it doesn't have to be. There's also a lot of work happening on domain-specific LLMs and fine-tune training for specific industries. So for example, NVIDIA launched their BioBERT, which is trained on a whole large volume of scientific journals and scientific papers. So that's a very custom model for science questions. There's a lot of different models coming out. There's a lot of different platforms. So what we call something like ChatGPT is basically called a foundational model. And what that means is it's a general model. So it has a lot of information about a wide variety of topics, general knowledge, but it might not have domain-specific knowledge. So if you're asking legal questions, or if you're asking scientific questions, or you're asking engineering questions, the level of expertise that it would be able to have is not as high as you might expect. So that's where fine-tuning and RAG and all the different optimization engines that our team is working on, that's customizing a foundational model to be used for a very specific use case, and to speed it up as well. So the foundational models, because they're general, they're basically trained on all of human knowledge. It has to go through a lot of data to give you an answer. So it's kind of slow. But if you have models that are trained on smaller subsets of data, you'll actually get much faster responses as well. And that's where domain-specific LLMs and fine-tuned models come in.
Okay, so now how does that work in the energy industry? So as Beta had mentioned, there's chatbots. That's one example of an application. But then there's other various forms of it as well. So you can see energy forecasting, assuming that you have a lot of historical data and different variables, you can now forecast energy a lot better as well. Also, for Edcom Energy specifically, we also have our P-track model, which is similar to this, where it takes a whole bunch of historical data and I believe 17 different variables, if I'm correct, and then we're able to predict what the Ontario grid is going to be doing. So that's just one example of an LLM, but then as well, we have our chatbot now, which is kind of more so our AI co-pilot that allows you to actually ask those questions. And so that can help with grid management, production optimization, assuming that you have a lot of production data, you're able to feed those into those models and able to optimize your overall processes. Emissions reporting, load scheduling. So load scheduling is going to be a big one because as you feed the model with different schedules that you may have for your own facility, it can learn off of that and then give you different insights based on what's happening from your own data. And then similarly, carbon emissions reductions as well. So that's just some examples, but again, what's going to happen in the future is probably endless because there's so much that you can do when you have a lot of data. And as we know in the energy industry, the issue is that we don't have enough. We actually have too much energy data floating around. We just don't really know what to do with it. So elevate your data. So now how do we elevate the data that we have? So a great feature of LLMs is that they allow us to kind of democratize the data that we have. It's an interface where even non-technical people have access to data they need. All you have to do is ask. So for an example of something like a chatbot, instead of having to have a software developer or someone who's a data scientist go through the data that you already have and run like queries and do different calculations to be able to get some sort of insight, now you can have your LLM actually do that for you and then just provide you the answer to the question that you're asking. And then that leads into enhanced operational efficiency because now we're reducing the data analysis and communication time. So imagine that you're in a large facility and you guys have production managers, maintenance managers, you have a sustainability team, and you want to get some information regarding an asset and maybe how it's been consuming energy. Across different organizations, that might look different, how you actually get the end result of that data. But now with an LLM model, you don't have to ask different people or try and figure out who the right person is to ask. You can just ask the model itself, and then it'll be able to provide you with the answers that you're looking for, which then leads to better decision making. Not only better decision making, but quicker decision making, which in sense is kind of better overall. So again, having instant access to your energy and carbon insights, so you're able to make decisions faster, and then those can trickle down within your organization faster as well. So if you're looking to make more sustainability initiatives, by being able to close the gap between how you're getting that data, you're able to implement more better sustainability strategies overall in a quicker time frame. Similarly, asset data for maintenance, upgrades, and optimizations, instead of trying to find the person who has all of the asset data and then going through it yourself and doing your own analysis, you can actually just ask the LLM model. So now we're kind of closing those communication gaps and making it more efficient for you to actually maintain your assets. And as we know, when your assets start needing repairs, or they start running out of line, that's when you start seeing an increase in costs, and then you have to implement some more energy efficiency strategies. So now you're kind of removing all of that because you're able to get the answers right when you want them and need them. And then similarly, if you're generating reports, if you're someone on an ESG team, you need a lot of different types of information to provide to whoever is mandating those reports. Now you can easily get it instead of going to an energy person, a financial person, and maybe a sustainability person. Similarly, with IoT and API integrations, again, you get even faster pieces of data, especially if you have them floating around in different platforms or different like SCADA systems and BAS. Now you can combine that all into one platform and then be able to get the answers right away. So again, just elaborating on some of the points that I just discussed. Anyone can fine-tune the model without programming knowledge. So again, anyone within an organization can start asking the right questions and getting the feedback that you need. And then essentially you're training the model for that facility. So again, that's teaching the model your restraints and parameters, not just yours, but your facilities. And then you can transform it into a co-pilot specific for your facility. So again, now you have your own chatbot just for that facility. And what's interesting about this too is if you are in a large organization that has multiple facilities, so for example, maybe you have one in Brampton and then maybe you have one in Toronto, the LLM will actually just look at that data for that specific location. So that's really important too. If you're someone who's managing multiple different locations, you can actually get the answers right away without having to search through a whole bunch of different data sources.
Yeah, so really it just makes accessing that data easier, and then it makes it much easier to interact with that data and get answers from the data, right? And then specific to your facility. So there's a lot of work happening there. Now, the elephant in the room. So a lot of people we talk to about AI and LLMs, and one of the first questions that comes back is, well, what is the sustainability benefits of using an AI model? I heard that ChatGPT uses, I think the most recent number was 17 times more energy than a Google search, right? But it's also providing a lot more value. So really the answer is, it is a problem, right? So LLMs definitely consume more energy because there's a huge computational requirement to train these models and also to run these models, right? There's thousands of parameters, billions and trillions of parameters that have to run through to train a model. And then every time there's a query that comes in, there's a lot of work that has to be done to process that information. So we know that OpenAI is utilizing Microsoft Azure's data centers, and there's a lot of work happening in data center optimization, data center sustainability, adding solar, adding fuel cells, adding wind energy. There's some rumblings about data centers connected directly to nuclear power plants to at least make them carbon free as well. And so it is kind of a double-edged sword. Our thinking behind AI models is that these LLMs are going to get a lot more efficient and a lot more fine-tuned as time goes on. So typically that's how it works with technology. At the beginning, it's very clunky, it's very large, it's very slow, but optimization doesn't happen until things reach the mass market, right? So now that these LLMs have reached the mass market, the optimization, the fine-tuning of the models, smaller models, different types of models for specific use cases, all of those things are going to come out, which is going to lead to significant efficiency improvements. But there's no two ways about it. This is going to increase the overall electricity consumption, which is going to exacerbate some of the problems we're already having on grids worldwide. So it's a double-edged sword. This is how innovation. This is what happens with innovation. Anytime something new comes, there's benefits and there's downsides. With AI, I think a lot of the downsides are going to get sorted out over the next 5 to 10 years. Now, when it comes to the use of the carbon emissions that result from a GPT model, so this was a really interesting case study, a really interesting scientific paper that we found. And really the study was comparing a query from an LLM to basically create one page of text versus if a person did an hour of work to create that same paper. And the amount of emissions that a person would create when it comes to heating their building, cooling their building, getting the internet access to them, and all that stuff actually ended up being significantly more than what the GPT model. Now, I'm not saying that all these GPT models are going to replace humans and humans are not going to have any emissions, but it's just an example of, because it's speeding up our output, it might actually end up making things more efficient in the long run, but it really remains to be seen what the results of that will look like. Now, when it comes to Edcom Energy's AI Copilot, so we've spent a lot of time talking about general LLMs sort of generic knowledge that some of you may or may not have interacted with in other places. When it comes to our AI Energy Copilot, we were recently awarded in April through Microsoft and ABB. They held a startup challenge. 800 companies worldwide competed for this program, and Edcom Energy came in the first place for the Copilot program. And what we'll be doing is we'll be going to market with ABB. We're launching an MVP, initial product that will prove out one use case of this Copilot. And that use case is load scheduling for an industrial facility, which Courtney touched on a little bit earlier. So users will be able to have a conversation with the Copilot, educate the Copilot on what are the constraints in my facility. Line 1 is producing a product that I can't change. Line 2 is producing a product that's due out next week. I have some EVs charging. I have some compressors. You are able to, through natural language, educate this Copilot on how you consume energy in your facility, what the constraints in your facility are, and then the Copilot takes that, combines it with tariff information, emissions information, and then it makes a recommendation for you on how should you actually schedule your facility, right? So if you have an energy manager, you have a sustainability manager, you have a big team analyzing this info, this maybe is not that helpful, but a lot of facilities don't have that or can't get those answers as fast as they'd like to because the grid is so dynamic nowadays. So with this launch, we'll be able to actually produce energy optimized facility load schedules that will help you significantly reduce emissions and reduce energy costs. And we're really excited about this. And the partnership with ABB and Microsoft is going to be huge in terms of the sustainability impact that Edcom can have worldwide. Now, getting a little bit more into the detail of our Copilot, right? So as many of you are familiar with our platform, and some of you may not be, I just want to touch on sort of the back end that is fed into this Copilot. So Edcom, really, our product portfolio has 3 pillars. One of them is called PTrack, which is a grid prediction engine. So what it does is it predicts energy prices, it predicts energy peaks, the demand peak, it predicts the emissions. So anything that has to do with the grid and basically understanding and projecting what the grid is going to look like in the next few hours, in the next few days, in the next few weeks, that goes into the PTrack platform. DataTrack is facility centric. So you want to know, what are my chillers doing? What are my boilers doing? What are my air compressors doing? We have a combination of an energy management system with really easy to install IoT devices, and these two work hand in hand. So not only will you know what's happening on the grid, now you actually know what's happening in your facility down to the asset level. On top of this, we've built NeuroCharge. So many facilities are going ahead and procuring battery energy storage systems, fuel cells, natural gas generation, or they have smart building automation systems. NeuroCharge allows Edcom to actually take control of certain parts of your operations, the non-critical parts that you're comfortable allowing somebody else to control, and we actually control those assets during peak events. So based on the price, based on the demand response event, we take all the data from PTrack and DataTrack and use that to optimize your DER asset as well. And then the Copilot is built as a platform kind of with an overview of all 3 of these products. And it's able to answer questions and give you insights across the product portfolio. And I think that's really what gives it a huge advantage, is the fact that it's connecting to grid data, it's connecting to your facility data, and then it's giving you insights that marry both of those factors into one place. So what are some of the things that the Copilot can do? So we're doing a lot of work on teaching and upgrading and improving the accuracy of the Copilot models, but also the capability of the model. So right now, what it can do, and we're going to get into a demo in the next few minutes where we're going to be showing all this stuff. But right now, what it can do is it can show you energy consumption usage. So if you want to just ask it, how much energy did my boiler use last week? It's able to do that. What are the costs associated with that? So I know my boiler used 10,000 kilowatt hours. How much did that cost me, right? Now compare boiler 1 to boiler 2, compare boiler to chiller. So it's able to do those comparisons for you. It's also able to give you minimum and maximum consumption ranges. So what was the lowest weekly energy consumption of the boiler over the past 6 months? It's able to analyze that for you. Sensor availability and health. So because it's connected to the IoT platform, which of my IoT sensors are running out of batteries? Let me know so I can go change them. Or which ones are having connectivity issues? So it takes all that data, and then now it's able to relay it into emissions data as well. So I want to know what were the scope 2 emissions related with my boiler last week, or over the past 6 months, or between 4 p.m. on Monday and 8 p.m. on Tuesday when I was producing widget A, what were the emissions associated with that line, the scope 2 emissions. And then it's able to do comparative analysis, emission calculations. It's able to analyze data in a CSV file. So if you want to import additional data that's not connected on the back end, you're able to do that. Troubleshooting and FAQ, and the ability to let you download CSV files, so then you can put these in reports or put them in some other format to share with your team. So now I'm really excited because we're going to get into the Copilot demo. So bear with me here as I bring it up and log in here. And we have some interesting questions that we can ask the Copilot. So the Copilot is right here, built into Edcom's overall software platform. The P-Track is right here as well. Data Track is right here as well. And all this data from P-Track and Data Track is what feeds the Copilot, so it's able to give you more insights. We have a traditional energy management system here. When you get into the Copilot, it gives you some example of questions. And really, we've structured the questions into energy insights, financial insights, and production insights. Right now, most of the work that has been done is on the energy insights side of the picture, but there's quite a bit of work happening on the financial and production insights as well. About a year ago, we launched this Copilot, the first version, and it wasn't able to do much. It was more of a proof of concept, but it's come a long way over the past year or so, and the capabilities that it has are truly, really exciting. So the first thing I want to do is I want to ask it, what sensors are you connected to? So by giving it this first prompt, you're able to be sure that it actually has the data that you want on the back end, and it's able to give you information based on those connected sensors. So in this example, this is a real customer case. So these are the different devices that the Copilot is connected to, and these are the measurements that it's providing, right? So now I'm able to ask it some very specific questions about each one of these devices. So I want to say, what was the main, so let's go with production line. What was production line one's energy consumption last week in kilowatt hours? Compare it to the week before. So now it's going in the back end, it's grabbing that data, it's converting this question that I have into Python code, mathematical code. It's doing the analysis of the data that it has back there. It's combining all the energy for that week, and then it's pulling the data for the week before that, and then it's going to compare the two of them, and hopefully sometime soon give us the answer. So you can see there was a consumption week over week. It's comparing them. And
just to elaborate a little bit here, we do have the capability to combine multiple assets or devices into what we call a production line. So if you know the production line has like 2 chillers and a compressor, you can put those into a group, to say the least. And that's kind of what we're looking at here. So if you're wondering if that number seems pretty high, that's why.
Yeah, thanks for that clarification.
Aggregation of multiple devices.
So it's multiple devices in one production line. Yeah, that makes a lot of sense. So now, in terms of production line, so what was production line one's weekly peak demand over the past 3 weeks? So now you want to know what was the peak demand that happened over the past 3 weeks and pull out that data. By understanding what the peak demand was, you'll be able to set alarms and then ensure that you don't hit that peak demand on a weekly basis, and you're able to reduce that as well. Now again, it's going in the back end, pulling the data, converting this text to a mathematical model first, asking those questions, and then coming back with a mathematical response as well. So now the weekly demand over the past 3 weeks, you can see, and it automatically knows that it should create a chart. I didn't ask it to give me the hour, but it was smart enough to know that the hour that that peak occurred was relevant and give us that example. Now I'm going to ask another question here, which is going to be a little bit different. So it's going to be what was so let's grab maybe production line. Let's grab maybe 3 of these, right? And let's say how much of the total. So let's compare them, right? Compare the energy consumption between. So now I want to know, was production line 2 consuming more or production line 1? And maybe once I know that, over the past 2 weeks, and give me the difference in percentage and in kilowatt hours. So now it should be able to analyze the two, give you a recommendation. Now, if you find out that one of them was much higher than the other one, well, why? Was it producing a different product? Was it not as efficient? Were there motors that needed to be upgraded? Were there devices that needed to be oiled? Was there filters that needed to be changed? So there's quite a bit of analysis that could happen on that front. Oh, and that one, it timed out. I think we asked it a little bit too much. So maybe let's ask it over the past week. So compare the energy consumption between over the past, let's say over the past week. It might have been too much data on the back end. Sometimes if there's too much data being fed into the mathematical model, it can't handle the volume. So then it just says, it gives up.
We are actively working on increasing the how much data we can feed into it and how accurate that will be.
So now it's, again, giving the example of how much one of them used versus how much the other one used. Now, there's some other examples that we would be able to ask it. So what was the cost per week for production line 1 over the past 2 weeks? Okay. What was the energy cost per week? So now we're getting into some of the cost functionality. And while it's working on that, we can look up here to see if there's any other questions that we could ask it. So I'm going to ask it a really hard one next. I'm going to try to trick it. So the energy cost was, so now it knows on a weekly basis. So now you're getting granular, right? You know exactly production line 1 cost me this much over the last week. So now, how much of the main energy cost is made up of production line 1 in percent?
Before you send that, I just want to highlight here, as the model is learning, as you do ask it questions, it kind of learns what kind of questions you like to ask, and it'll even give you further recommendations based on the last question you asked. So you can see those 3 prompts that are available now.
Mm-hmm. So these are recommended questions.
Exactly.
I'm trying to trick it. Let's see if this will work. It's kind of weird wording too.
Yeah.
Let's see. This is how I keep the tech team on their toes.
Thinking.
There's a lot of data there. So I was able to figure that out. Now, all this data has also been verified, right? So these LLMs are notorious for making up data sometimes. But what we've done is, because we've done a lot of fine tuning and a lot of testing, we verified that the percentages and the data that it provides are true. So now another thing that you can ask it is uptime of devices, interval data of your main, breakdown of yesterday's energy consumption for the facility. And let's just try one more question. So give me a breakdown of each device's energy cost for yesterday, right? So let's see how it does on this one. Again, a lot of data being processed on the back end, multiple sensors, has to convert it to math, pull out that data, analyze it, And let's see if it's able to do it, because breakdown is pretty generic, right? So give me a breakdown is pretty generic. So how it decides to answer, is it going to give us percentages, kilowatt hours? I don't know, right? So I did it on a per cost, right? Energy cost. And you can see this was the cost of those specific devices from yesterday. Now so this is again an example of some of the capabilities that the AI Copilot has. It's really limitless what the capabilities are going to be over the next few months and over the next few years. There's a lot of work being done on providing this with more and more data, more and more capabilities. And now I want to get into sort of our vision for what it's going to do in the future. I lost my presentation.
I went through a lot. Okay, so our visions. We want to create the next generation of energy management tool. So as you saw, the AI Copilot can answer questions relating to energy, financial insights, production. These are all things that, from experience and talking to our customers, we've learned these are all really relevant to energy management. And a lot of energy managers are constantly looking for this type of information as well to be able to do their job properly. But right now, this is just based on customer feedback. As we start rolling out the product more, we're going to be getting more feedback from more people. We'll be able to add some more capabilities based on what's going on in different types of facilities. System automation through LLMs. Currently, it's all about data, information, and visibility. The next stage is to allow LLMs to leverage the data and automate processes for optimal energy, emission, and production. So right now, at this point, we're kind of limited to a chatbot. It's just a conversation that we're having with this AI Copilot. In the future, though, we'd like it to be able to actually act on some of the insights that it's giving us. So if it's saying that we should shift our production from production line 1 to line 2 at this time, we'd actually want it to be able to do that as well. So if we can integrate the AI Copilot into control systems, BAS, SCADA systems, then we
NeuroCharge.
Exactly, and NeuroCharge, which would be able allow you to discharge your battery at different times that are that the AI Copilot would deem as beneficial. Then that would be the next step. And then that would essentially give so much more room for energy managers to work on other things and other goals in terms of sustainability, instead of just managing and setting up processes, because now you have someone else to do that for you. And again, to summarize, so that would be automated and optimized load scheduling, which is also what we're working on with ABB. So we're really working with someone who has a lot of insight into this industry already. And again, with our customer feedback that we've already been able to get up until this point, we really want to be able to create something that's valuable for energy managers and other people within the energy industry. And I think the best way to do that would be able to actually implement the insights that the AI Copilot is giving us.
Yeah, and I think, energy management and sustainability management, really the first step is understanding what could happen and then improving it and then controlling it, right? So right now with the Copilot, really it's focusing on understanding, right? Mm-hmm. What were my emissions? What was my consumption? What was my cost? But over time, improving and controlling are going to be a bigger part of what the Copilot is going to be able to do. And the fact that we have the ability to control DERs already, that software is already figured out, it's just not fully connected to the LLM. The LLM is not allowed to actually change parameters in a plant yet, but eventually it will be able to. Yeah. So that just leaves a lot of time for the person to do more creative work and more sales type work.
Exactly.
Right?
And then that's kind of the final step too, right? Is if you analyze every little piece of equipment that you have in your facility, and then you realize there's limitations, things that you can't move forward with in terms of curtailment or load shifting or shutting down, and introducing a DER or battery storage now gives you those capabilities you didn't have before. And combined with someone able to control it that isn't you, that would be a really easier job, I'd say, for energy managers.
Much easier.
Okay, so we did talk about some of our other products that we have. So just to give a general overview of our ecosystem, we are not just an AI Copilot. As mentioned, we do have various products. We talked about P-Track, which is our peak prediction software. We have Data Track, which allows you to view all of your assets in one place through our IoT sensors. We have NeuroCharge, which allows you to now get into BES and DERs, and we can dispatch your battery for you. So with all those different services that we offer, there is a lot of data associated with them. But having the AI Copilot, again, as Beta had mentioned, sitting over top of everything allows an easier way for you to get the data between all those services in one place. So yeah, if you guys have any questions regarding these services, we'll be more than happy to talk about them. Again, this webinar was mostly focusing on the Copilot itself, so we didn't want to get too technical into what else we're offering. But if you guys have any other questions regarding those, we'd be more than happy to answer them.
Yeah, thank you very much for your time, and we're really excited about how AI is going to change the world of energy management. If you have any questions or if you have any feedback on this webinar, or any ideas of how we could improve what the Copilot is doing for your facility or for anyone else who might be interested, definitely reach out to us. We're constantly improving the capabilities of this platform, and we're really excited for what the future holds. Thank you.
Yep, thank you. Any questions?
If anyone has questions, you can just drop them in the chat. We're still here for the next couple of minutes. Okay. Thank you, everyone.
Thank you.